This is section 8.1, question 4. It's so long, I don't know if I can get it all on here so that it's readable. It's pretty small. Well, we'll do the best we can. Let's see. What do we have here? How much customers buy is a direct result of how much time they spend in a store. A study of average shopping times in a large national houseware store gave the following information, and they sourced it right here. All right, so what do we have here? Women with a female companion, 8.3 minutes. Women with a male companion, 4.5 minutes. And what these are, these 8.3 and 4.5, that is the average shopping time that women spent in a store with a female or male companion. Now here's part A. Suppose you want to set up a statistical test to challenge the claim that a woman with a female friend spends an average of 8.3 minutes in such a store. Okay, so we want to challenge the claim that the woman with a female friend spends 8.3 minutes in the store. What would you use as the null and alternate hypothesis if you believe the average shopping time is less than 3? Well, if you believe that it's less than 3, I think we're looking at one that says the alternate is, right, that's the alternate less than 3. So we're going to claim that it's, we want to show this. So we're going to, the norm would be this one right here. H naught would state that it is 3. We want to show that we could reject this, nullify this, right? The null hypothesis. We want to see if we can nullify this and go with this. So I'm going to go with that one right there. And then the question is this a right, left, or two-tailed test? Well, this is a left-tailed test. We're pointing, the arrow points towards the left tail. So this is a left-tailed test. Then, part B, what would you use for the null and alternate hypothesis if you believe the average shopping time is different? Okay, it's just different. It doesn't say less than, greater than. It's just not 8.3. All right, so how about this one? This is what we believe. That's what we want to show. So we believe it's this one. We want to show this one. So we want to nullify this. We want to see if there is enough evidence to nullify this in favor of this. So it's not going to be, well, this is never true. It's not greater than or less than. Let's go with this one right here. Oh, and then there's this part down here. Is this a right, left, or two-tailed test? Well, the arrow, there is no arrow pointing. It's just not equal to. So that is a two-tailed test. Right? We're going to claim this a two-tailed test. And then what have we got down here? Stores that sell mainly to women should figure out a way to engage the interest of men. Perhaps comfortable seats and a big TV with sports programs. Suppose such an entertainment center was installed and you now wish to challenge the claim that a woman with a male friend spends only 4.5 minutes in a houseware store. All right, so what do we want to do? We want to challenge the claim that a woman with a male friend spends only 4.5 minutes in the store. So part C then is, what would you use as the null and alternate hypotheses if you believe that the shopping time is more than 4.5 minutes? Okay, well, we think that it's more than 4.5 minutes, so it seems like we're going to have a greater than. That's an equal. That doesn't make sense. The null hypothesis, all we've got an equal in it. That's out. Less than, greater than. How about this one here? That's a greater than. So the standard is 4.5. We want to see if we can nullify this in favor of more than 4.5. So let's go with that one. Left tail, right tail. I think it's a right tail test. The arrow is pointing to the right tail. Part D says, what would you use for the null and alternate hypothesis if you believe the average time is different? Okay, different, they're just trying to get us used to using less thans, greater thans, or not equal to. If it's different, it's not less than or greater than, it's just different. So the null hypothesis, the one we're trying to nullify is this one here, that is equal to 4.5, And we just want to nullify it in favor that it's different. It's not equal to 4.5. So let's go here, and this is a two-tailed test.